Now let us study about the coagulation of the salt particles. The process of settling of colloidal particles is called as either coagulation or precipitation of the salt. Now this can be done by using different methods. Particularly the lyophobic salts are unstable, so they can be precipitated by using different methods. The first one is the electrophoresis. Now during electrophoresis, the salt particles move in the direction opposite to the charge carried by them. For example, if the salt particles have negative charge, they move towards the anode, which is positively charged pole. There the salt particles get neutralized. The charge on the salt particles get neutralized so that they precipitate. Now by mixing two oppositely charged salts, let us take hydrated ferric oxide salt, which is a positively charged salt, and also arsenious sulfide salt, which is a negatively charged salt. If these two salts are mixed in equal proportions, it brings them in the precipitated form. So because the charge on the two salts get neutralized, so that the salt is precipitated. So this type of coagulation is called as the mutual coagulation. Now next one is that by boiling. So when a soil is boiled, the adsorbent layer is disturbed. It is due to the reason that there will be increased collisions of the adsorbent layer with the molecules of dispersion medium, which reduces the charge on the particles, and finally they settle down. Now the next one is that by persistent dialysis. So during dialysis, the impurities are removed. Sometimes a small amount of electrolyte is essential for the stability of the salt. If the dialysis is carried out for a long time, that is on prolonged dialysis, even the traces of the electrolyte present in the salt are removed, so that the colloid becomes unstable and ultimately it precipitates. Now the next one is that by addition of electrolytes. When an excess of electrolyte is added, the colloidal particles are precipitated. The reason is that the colloids interact with the ions carrying charge opposite to that present on themselves. This causes neutralization. Finally, it leads to the coagulation of the salt. For example, let us assume that the salt particles have negative charge. When an excess of electrolyte is added, so electrolyte has both positively and negatively charged ions. Now the salt particles have negative charge. So the salt particles interact with the positive ions of the electrolyte, which causes the neutralization, leading to the coagulation of the salt. Now the ion that is responsible for neutralization of charge on the colloidal salt particles is called as coagulating ion. So a negative ion causes the precipitation of positively charged salt. Similarly, a positive ion causes the precipitation of negatively charged salt. Hardy-Skells rule. It states that greater the valency of fluctuating ion added, the greater is its power to cause coagulation. For example, in the coagulation of negatively charged salt, the fluctuating power is in the order. Now these are the positive ions, and as we have already learned, the positive ions cause the precipitation of negatively charged salt. Now among these positive ions, the one which has higher charge causes greater coagulation. So that is the fluctuating power or the coagulating power will be higher if the charge is higher. So sodium ions, the coagulating power of the sodium ion is less than that of the barium ion, which itself is less than that of the aluminum ion, because aluminum ion valency is 3, that is charge is 3 plus, hence it has highest fluctuating power. Similarly, we have already learnt the negative ions cause the precipitation of a positively charged salt. Among the negative ions, the one which has higher negative charge causes more precipitation. So this will be the order. Cl minus is less than SO4 2 minus is less than PO4 3 minus, which is less than FeCN6 4 minus. Now this ion has highest negative charge, so it will have greater coagulation power. Now coming to the last topic of this chapter, that is emulsions. Now emulsion is a colloid in which both dispersed phase and dispersion medium are liquids. So it's a liquid-liquid colloidal system. It's a liquid-liquid colloidal system. Now we have two types of emulsions. That is oil in water type, then water in oil type. Oil in water type emulsions. So here water is the dispersion medium and oil is the dispersed phase. You can observe here the small particles are oil particles, whereas this dispersion medium is the water. The second one is water in oil type. Here water is the dispersed phase, whereas oil is the dispersion medium. Right. For the oil in water type emulsions, we have milk and vanishing cream. And the examples for the second type, that is water in oil type, we have butter and cream. Now you must know that how do we identify that the emulsion given is whether it is oil in water type or water in oil type. It can be identified that suppose dispersion medium is added to the emulsion, there will not be formation of any separate layer. That means the emulsion can be diluted with any amount of the dispersion medium, so that no separate layer is formed. Suppose for oil in water type emulsion, this is oil in water type emulsion, right? So if water is added to this emulsion, no separate layer is formed. But once the oil is added, a separate layer is formed. Similarly, for water in oil type emulsion, so we can add any amount of oil, but once water is added, a separate layer is formed. So emulsion can be diluted with any amount of dispersion medium. So the emulsions of oil in water type are unstable, and sometimes they separate into two layers on standing. So for stabilization of these emulsions, a third component called as emulsifying agent is commonly added. So a third substance, a foreign substance, is added to the oil in water type emulsions to make the emulsion stable. The emulsifying agents form an interfacial film between suspended particles and the medium. So the principal emulsifying agents for oil in water type emulsions are proteins, gums, natural and synthetic soaps, etc. So actually these synthetic soaps are the best examples for the emulsifying agents. And for water in oil type emulsions, we have heavy metal salts, fatty acids, long chain alcohols, lamp black, etc. Thank you.